In this video, we will look at how to create a two-dimensional array, what a two-dimensional array is, how to edit the array, and how to assign the values of the array to buttons in Tkinter. A one-dimensional array in Python is known as a list. As you may know, lists are declared by writing a variable name, and then an open and close square bracket, which is then separated by commas. Let's create this quickly, by creating a new Python file named basics12 and writing 1_d equals, open square bracket, apostrophe, first value, apostrophe, comma, apostrophe. Second value, apostrophe, comma, apostrophe, third value, apostrophe, close square bracket. On the line underneath, print the statement by typing, print, open bracket, 1_d, close bracket. If we run the code, we can now see we have a basic list, otherwise known as an array, printed to our shell window. If we edit the print statement and after the 1_d statement we type, square bracket, 0, square bracket, then run the code, we see that the first item is brought back. So, what is a two-dimensional array? Well, whereas a one-dimensional array has all its values contained within a single line or an axis, which can be seen in the print statement within the square brackets, a two-dimensional has its values contained within an x and a y axis. So instead of a single set of square brackets to identify the value within the array, we would have two sets of square brackets. Let's code out this so that we can visualize it better. In Python, on a new line, create a new variable named 2_d by typing 2_d equals symbol, open square bracket. Then type another open square bracket and type 1, 2, 3, then a close square bracket. Then type, open square bracket, 4, 5, 6, close square bracket. Then type, open square bracket, 7, 8, 9, close square bracket. Then type, open square bracket, 10, 11, 12, close square bracket. Then finally type another close square bracket. Here we can see that we have square brackets enclosed inside our main square brackets, all separated by commas, and all containing their own sets of data. Let's write a print statement underneath this line of code. Type, print, open bracket, 2_d, open square bracket, 0, close square bracket, close bracket. Then run the code. Here we can see, where the one-dimensional array brings back the first value, for the two-dimensional array, the first value is the first set of values in the array. So, if we want to specify a specific value within the first set of values, in the print statement, after the square brackets, type another set of square brackets, and put the number 0 between them. Then if we run the code, we will see that only the first value, for the first set, is brought back. As we have two sets of square brackets, you can see what the two dimensions are. The first dimension is considered as the x-axis, or the row. And the second square brackets would be the y-axis, or the column. To help visualize the rows and columns better, in the 2_d variable, after the first set of square brackets, otherwise known as the x-axis, or the row, after the comma, press enter. Do this for all the rows. This helps to visualize the array better, as we can now see a grid starting to form, with values going across, which are the rows, and values going down, which are the columns. So, if we wanted to return the value 11 from our two-dimensional array, in the print statement, we would type 3 within the first set of square brackets, and 1 within the second. Remember that lists start from 0 instead of 1, which is why we type 3 instead of 4, and 1 instead of 2. When we run the code, we can see that the correct value of 11 is brought back. So, what if we wanted to modify a value in the 2D array? Well, on a new line down, type 2_d, open square bracket, 0, close square bracket, then another open square bracket, 0. And another close square bracket. Then type, equals symbol, then type 100. What we're doing here is taking the value in row 0, column 0, and changing its value, which was originally 1, to the value of 100. Now if we type another print statement on a new line, by typing print, open bracket, 2, underscore, d, close bracket. Then run the code. We can see that the first value has now been updated. So, what if we wanted to iterate over all the values in the 2D array? Well, to do this we could use a nested for loop. But first we need to define the number of values in the rows and columns so we can iterate over them. On a new line type, rows, equals symbol, len, open bracket, 2, underscore, d, close bracket. Then on the next line down, type, cols, equals symbol, len, open bracket, 2, underscore, d, open square bracket, 0, close square bracket, close bracket. What this does, is it uses the len function, to count how many rows there are, or in other words how many sets there are in the 2, underscore, d, array, and then for the columns. It counts how many values are in the first row or first set of data. So, for rows it will bring back a value of 4 and for columns it will bring back a value of 3. So, in order to iterate over these values, on a new line, type 4x in, range, open bracket, rows, close bracket, colon. Then enter a line down. Now type 4y in, range, open bracket, cols, close bracket, colon. Then enter a line down. Then type print, open bracket, 2, underscore, d, open square bracket, x, close square bracket, open square bracket, y, close square bracket, close bracket. Now if we run this code, we can see that all the values are printed out. Here we can see, the first for loop, loops through each row, and for each row, the second for loop, loops through each column value. This is great if each of our rows contains the same number of columns, but what if for instance, our third row, contained 4 columns? Let's try this out in the 2, underscore, d, variable, on the third row, at the end type, comma, 9000. Then run the code. Here we can see that the 9000 isn't brought back in the shell window. This is because the number of columns we provide in the while for loop is static. It only counts how many columns are in the first set of rows, for example how many are in row 0. So how would we loop through a two-dimensional array, with an odd number of columns? Well, we can do this by modifying the code in or for loops. In the X for loop, instead of typing the word rows, let's just enter the formula that brings us back the row number, by typing len, open bracket, 2, underscore, d, close bracket. We can then comment out the rows variable, as it is no longer needed. Now, for the while loop, remove the word cols, and instead type len, open bracket, 2, underscore, d, open square bracket, x, close square bracket, close bracket. Now we can comment out the cols code, as it's no longer used. Now if we run the code, we can see that the value of 9000 is brought back, and all values in the array are displayed even though there is an odd number of columns. This is because we are dynamically updating the row number in our loop, which then works out how many columns are in each row. In most cases, it's good practice to have the same number of columns in each row, so we won't need to use this method, but it's always good to do it if needed. Now, let's have a look at how to use this two-dimensional array in order to create multiple buttons on a Tkinter window. First let's create a Tkinter window. At the top of the code, enter a few new lines. Let's import the Tkinter library by typing import Tkinter as tk. Then let's create a window. On a new line, type window equals symbol tk dot tk open bracket close bracket. Then on the next line down, let's set the window resolution by typing window.geometry, open bracket, apostrophe, 600 x 500 apostrophe, close bracket. Now let's close the loop. At the bottom of the script, enter a new line and type window.main, loop, open bracket, close bracket. If we run the code now, we can see we have a basic Tkinter window created with a resolution of 600 by 500 pixels. In our for loop, where we have the print statement, which prints to the shell window, remove the print section, and assign the value to a variable named var1. This will assign the value to a variable rather than printing it to the shell window. Now, let's create our buttons. On the next line down, under the var1 statement, type buttons equals symbol, open bracket, t, k, dot, button, open bracket, window, comma, text equals symbol, var1, comma. This will assign the value from the row and column, which we defined in our var1 statement, to the text of our button. Then type font equals symbol, open bracket, apostrophe, Arial, apostrophe, comma, 40, close bracket, close bracket. So, what we are doing is, for each row and each column in the loop, we are creating a new button called buttons, which gets its text assigned via the var1 variable. Now we need a method to place the buttons on the window, as the width and height placement will need to be updated with each loop so that they aren't all placed on top of each other. To do this, first let's create an empty variable for width and height. Above our loops, type width equals symbol 0. Then enter a line down and type height equals symbol 0. Now we can refer to these width and height variables within our loop. So, go to the next line down in the for loop, under the buttons variable and type buttons dot place open bracket x equals width, comma, y equals height, close bracket. This will take the value from our width and height variables, which we just created. Currently they are set to 0, so we need to update them with each loop. Enter down a new line and type width equals symbol width plus symbol 150. This will add 150 pixels to the placement of the width each time the loop is iterated over. Next, enter down a new line and backspace once to remove the indent. Now type height equals symbol height plus symbol 110. This will add 110 to the height each time the X loop runs. In other words, for each row of buttons that is created, the next row will be placed 110 pixels down. Now press enter and type width equals 0. This is because we want to reset the width to 0 every time a row has reached the end column, so that the next row isn't added to the right of the current row. Now if we run the code, we can see that all the buttons have been created. At the moment, all the buttons are different sizes. Let's change this in the buttons variable, on the end, before the close bracket, type, comma, width equals symbol 4. Then run the code again. This now looks a lot neater. So, what if we want to code the buttons to do something? Well, let's change the code a little, where we create and place our buttons, change the name from buttons to _d. Open square bracket, x, close square bracket, open square bracket, y, close square bracket. This dynamically names the button for each iteration of the loop. Do the same for the place statement, by removing the button's name and typing _d, open square bracket, x, close square bracket, open square bracket, y, close square bracket. Now that the buttons have individual names, let's add a command into our button, in the button variable. After we assign the text of var1, type, comma, command, equals symbol, lambda, row, equals symbol, x, comma, column, equals symbol, y, colon, test, underscore, func, open bracket, row, comma, column, close bracket, comma. What this code does is, it creates a lambda command so that the button code only executes when pressed. It passes the variables named row and column, which are assigned by the current loop's x and y position, and passes these values through to a new function called testfunc. We haven't created testfunc yet, so let's do this now. Above where we created the width and height variables, above our for loops, create a function by typing def test underscore func, open bracket, row, comma, column, close bracket, colon. Then press Enter. This is the statement that defines our function. Now type print, open bracket, 2, underscore, d, open square bracket, row, close square bracket, open square bracket, column, close square bracket. Dot c, get, open bracket, apostrophe, text, apostrophe, close bracket, close bracket. What this code does, is it prints to the shell window, the value of whatever text is in the current button pressed, by using the cget method and referring to our two-dimensional button name. If we run the code now, we can see that, whenever we press a button, the button's text is printed to the shell window. In this video, we have covered the basics of a two-dimensional array, and how it's updated and used to store values and create buttons. Whilst the buttons created using this method allow us to simplify code, sometimes it's easier just to create individual buttons so that we can clearly see the code for each button. It just depends how you like to code, as there are multiple ways in code to reach the same solution. Hopefully you now have a better understanding of the two-dimensional array in Python.